Yeah, camps on everyone. Let's start off. Great. So last thing that we did was average velocity and average speed. Hope everyone has gone through the notes. Great. Others do keep your cams on. The next thing, average acceleration. So average acceleration is simply change in velocity by time. Delta V bar by delta T, which is V final minus V initial by time. Similarly, we define something called instantaneous acceleration. Now, be careful with this wording, right? If they simply say find acceleration, they're talking about instantaneous acceleration. So instantaneous acceleration is like the full name, right? So this is nothing but limit delta t tends to zero. That means when you take time very, very small, the average acceleration, delta v bar by delta t, you know what happens? This becomes dv by dt. That's the mathematical way of representing, but yeah, you got it. So if they ask you instantaneous acceleration, it is dv by dt differential. If you want average acceleration, it is change in velocity by time. So acceleration can be written as dv by dt, right? This can be also written as v dv dot v dv dr. The actual form is this, everyone. So a bar is given by vx dvx by dx. So vx is the velocity in x direction. If you differentiate vy dvy by dy, this is your acceleration in j cap, vz dvz by dz. There. So this each component here, this term here gives you, this is ax, which is acceleration along x-axis. So if you want to write acceleration in 3D, right, this is the form. So till now we have been using this v dv by dx, but that's only in one dimension. What if you have acceleration both in x, y, and z? So this is acceleration along x-axis. This term is ay, acceleration in y-axis. This term is az, acceleration in z-axis. That is the vector form. All clear with this? Any doubts on this? Dhruv, Manav, Soumya, Kamson. Clear so far? Rohit, Karthik? Clear? Let's go ahead. Let's go ahead with the problem. Last thing we did was this average thing. This is a standard one. We have already seen this thing. I think this is the third time, I guess. We have a circle of radius r. We have a particle here, which is going with speed u. T0, this is your origin 0, 0. This is your x-axis and this is your y-axis. So initially this particle is at r, 0. So the particle is going in a circle with a constant speed u. Hope you guys remember this. We have done this in different places like vectors, differentiation. This is a good one, right? This will explain you different things. Let's see. Mathematically, how you can do things. The first thing, standard one, find the position vector as function of time t. Find mode of average velocity at time t. Find d mod r by dt and mod dr by dt. These are completely two different things. I'm putting a look at the first one. This is d. You're differentiating the modulus of r. Here you're differentiating r bar and then you're taking the modulus. Putting the mod in and out will change the whole meaning of it. Find average acceleration at time t. Find d mod v bar by dt. dv bar by dt ka mod. I'll add more here. F. Find integral v bar dt 0 to pi r by u. Integral mod v bar dt 0 to pi r by u. There, let's get all of them. So here we are just playing with that modulus, putting a mod in and out. Like, what does it even mean? Let's start from the first two. These are easy ones. There's nothing there to think there. Get the position vector. What is average velocity? Displacement by time. What is displacement? Final minus initial. The first thing we have done in vectors. Again, if you actually try to understand the meaning of this mod and everything, don't look at them and get scared. Like I keep saying, when you see a question and you feel it is weird, first thing, don't panic. When you panic, even a rope looks like a snake. But let's get the first one. That must be the easy one. If you have revised your notes thoroughly, you should be able to handle it by now. Yeah. Right, Karthik. Keep going. Get me the second one also. Your answer will come in terms of u, r, and time. That's it. There is no other variable anyway. Right, Rohit. First one is fine. Get me the second answer. I'll show you A and B together in a minute. We have done A and B before. We did it in basic math and vectors. There. This was the same question. Find the velocity vector, I guess. Here I asked you. So we did something of this sort. Okay, let's see the first one. So we got a circle. After time t, this particle will travel a distance of ut. It will go along the arc length, isn't it? So this distance will be u into t. This angle is theta. What is theta? Arc length by radius. What is the arc length? Ut. That is the distance traveled by the particle after time t. So the particle will be going like this at time t. So theta is nothing but ut by r. Great, we got theta. From here, drop a perpendicular. This will be your x coordinate, which is r cos theta. This will be your y coordinate, which is r sin theta. What is the position vector? Position vector is nothing but x coordinate, which is r cos theta. Theta is ut by r. So I'll just leave it like this. And r sin theta j cap. You can substitute theta there. This is your position vector. This is the position vector at any time t. What are you asking? Find the average velocity. So this is the first part. For average velocity, we need displacement. What is displacement? R final minus R initial. R final is this guy at time t. And what is R initial? R initial is nothing but when theta is 0, R initial is simply R I cap. Isn't it? Because initially the particle is here, t is equal to 0 on x-axis. That is simply R I cap. So subtract them. Subtract all I caps together, you'll get R cos theta minus R I cap plus R sin theta j cap. This is your displacement vector, right? So you want average velocity, just displacement by time will give you average velocity. But they're asking you for magnitude, so I will get the magnitude here. So this is a displacement. It will be root over square this. That will be r square into cos theta minus 1 whole square plus r square sine square theta. R comes out of the root. Inside you have cos square theta plus sine square theta. That becomes 1. This is minus 2 cos theta. And that becomes plus 1. I skipped a step. So please check it out. That will give you 1 minus 2 minus 2 cos theta. That is r into root over 2 into 1 minus cos theta. And hope you remember this. 1 minus cos theta can be written as 2 sine square theta by 2. That is 2 into 2 sine square theta by 2. That comes out to be 2r sine theta by 2. You have seen this multiple times by now already. 1 minus cos theta, 1 plus cos theta. By now you should mug it up, like remember it. You can't keep forgetting it. So you saw, right? This thing, I think, in 3 chapters so far, you must have seen this at least 5th or 6th time. This is already. Oh, yeah, displacement. So what do you want to find? Average velocity. So magnitude of average velocity is magnitude of displacement by time. Time is t. Then just substitute there. So 2r sine theta by 2 by time. That's your answer for the B part. All clear with this? So find your initial vector, subtract them, get the magnitude. So this is all vectors ka question. There is, frankly speaking, nothing in kinematics as such. So yeah, can you go with C, D, E, F, G? Let's go. I'll give another 2 minutes. But any doubts on A and B part, please ask me. Anyone not convinced with the coordinates or the magnitude or 1 minus cos theta, anything that you're not clear here? Great. Let's go with the rest. What is d mod r by dt? What is mod dr by dt? Understand the meaning of it. Like when you're putting a mod and putting the mod outside, how does it change, right, Anna? Keep going. Yeah. Keep going, keep going. Right. Nee, Karthik, right, Ahna? Let's try to understand, okay? What do you mean by d mod r by dt? So, yeah, let's write this on the next page. Now, let's understand this, okay? What is dr by dt? Dr by dt is v bar, which is velocity. Okay. What is mod dr by dt? This is mod v bar. This is speed. What is d mod r by dt? So first of all, ask yourself, what is mod r bar? It is the length of the vector, isn't it? And you're saying differentiation of the length of the vector. So this is not speed. D mod r by dt is not speed. This is rate of change of magnitude of the position vector. This is not speed. This is something else completely. This has nothing to do with speed. Are you clear with this? That is something else. Getting it? Now, getting back to the question. What is mod r bar? Mod r bar is r. So if I differentiate this, what do I get? Is the length of the vector changing when you're rotating? No, right? So 0. So simply ask yourself, what is mod r bar? Mod r bar is the radius of the vector. Is this changing? No, it is constant. No matter how much you rotate, the vector ka magnitude doesn't change. So if you differentiate, what do you get? You get a 0. Make sense? What is r bar? R bar is r cos theta I cap, r cos ut by r I cap, r sin ut by r j cap. So what are you asking? You're asking dr by dt. This is fine. So just differentiate this. You know what happens when you differentiate a cos, you'll get a minus sign. There will be minus u sin ut by r I cap plus u cos ut by r j cap. There. Now, if I ask you mod of this is actually the speed u. Hope you're getting the difference. Both are not same. Most people think that d mod r by dt is speed. And mod of dr by dt was speed. So this is something else. So what is it? We will see that in the next question. That also has a meaning. But is everyone clear with the C part? So if you differentiate the mod of r, it is a rate of change of the magnitude of the vector. They are completely two different things. Yeah. Right, Ahana. Keep going. What about D, E, F, G? Let's go. So you need to keep asking yourself, okay, what am I integrating? What am I differentiating? Am I integrating a vector? Am I integrating a scalar? So don't blindly try to remember it. Try to ask. Yeah, D is long to type. You can leave that. Get the rest. When people keep saying, right, think, what do you mean by thinking? It's nothing but asking yourself questions like, okay, what is this? What is happening with this? When you keep asking yourself questions and you try to figure out answers for that. Yeah, sometimes you won't get it. That's okay. What about D, average acceleration? That's an easy one, right? V final minus V initial. So this is your V bar. Average acceleration is V final bar minus V initial bar by time. V final is minus U sine theta I cap plus U cos theta j cap. What was the initial vector? It is going up, U j cap by time. I didn't ask you for magnitude, so I can leave it like this. If I ask you for magnitude, you will get something similar to the displacement thing, average velocity thing. 2u sine theta by 2, you will get the same stuff. So that's fine. What about E? D mod V by dt, mod dv by dt. F and G, integral V bar dt from 0 to pi r by u, integral mod V dt 0 to pi r by u. How is mod r? Seriously? That's your doubt. Mod r is what? It is the length of a vector. And how is this vector going in a circle? What is the radius of a circle r? You can just get the magnitude from here, right? R square cos square theta plus R square sin square theta. Yeah. Is that clear? Yeah, okay.
So for the
What about
C1, yeah, so for the
ask flow?
C1, how did we get sin ut by r?
How did we get? Because theta is ut by r, right?
Oh yeah, yes sir, got it.
Theta we already proved, na ut by r. So I just kept it.
Sir, but I have a doubt. Yeah, in the C part,
Mm-hmm.
like, yeah, the same question, but we just got mod R is equal to 2R sine, like displacement ka mod 2R sine theta by 2.
This is a displacement, yes.
And, so, oh, yeah, position and, oh, yeah, I just mixed two things. Sorry, sorry.
Yeah. Displacement is not r bar. Displacement is delta r bar. What about E? Again, ask yourself, what is dV by dt? Acceleration. What is mod dV by dt? Magnitude of acceleration. What is d mod V by dt? This is a rate of change of speed. This is not acceleration. They're completely different things. Now coming back to our question. Now tell me, when the particle is going in a circle, is the speed changing? Speed is constant. So d mod V by dt is zero since speed is constant. And what is dV by dt? That we can find. We know V bar, which is what we calculated here already, minus u sine ut by r I cap plus u cos ut by r. Jacob, in case you're still wondering, oh, how are we doing this? We have done this in pretty detailed in differentiation. This was the question, if you guys remember. Particle is going in a circle, find r bar, find v bar, find a bar. Remember this thing? Differential of 2001 times. This is the first time you have seen this question, actually. It's not the first time. Dekho, ut by r. I wrote everything here. Every time we kept on writing ut by r. I'm skipping that step now. So you can refer to this, page 48. If you see, I kept a star also. So in case you're still wondering, this was done before. So I'll just write down somewhere here. This is not a completely new thing, but yeah, but the mod things are new. So you want dv bar by dt, yeah, just differentiate this. So I hope everyone remembers the differentiation thing. Every time you differentiate, the function inside will keep coming out. You get minus u square by r, sine becomes cos. This is minus u square by r, cos becomes minus sine, so minus comes out. Jacob, there. Did I ask you mod or only dv by dt? I asked you mod. So mod of dv by dt, sine square plus cos square is anywhere 1, so that would be u square by r. Check. That's the difference. D mod v by dt, mod of dv by dt. Putting that mod inside and outside will change your whole answer. They mean completely two different things. Any doubts on this? Question is still not over. This is a big one. What about the integrals? What is integral v bar dt? What is integral mod v dt? Again, don't try to see it mathematically. Ask yourself, okay, like, what is v dt? V is velocity into time is what? Velocity into time is displacement. What is mod v bar? Speed. What is speed into time? Distance. So indirectly, that integral is asking you for displacement and distance over a time limit. G1 nere. How did you get that? You should definitely try this whole thing again on your own. It's not difficult, but yeah, this is the first time you're seeing that mod ka thing we are playing around. So ask yourself, so what is integral v bar dt? This is simply displacement. And what are you giving? You're asking 0 to pi r by u. What is pi r by u exactly? When time t is 0, you're here. When time is pi r by u, you have completed half the circle, isn't it? You're here. This is your final position. This is your initial. So indirectly, you're asking me find the displacement when the time is from 0 to pi r by u. Isn't this what you're asking? I really don't care how it is going. Displacement is simply initial minus final. So what is the answer for this? 2r minus I cap because it's going backward. That's your answer. Easy, right? There's no need to actually do any integration if you actually understand what it means. Velocity into time is displacement. And you're giving limits from 0 to pi r by u. You're going in a circle. Pi r by u meaning it's a semicircle. So you're indirectly asking me find the displacement when you have completed an half circle. Is that making sense? Similarly, when you say integral mod v dt, you're asking distance traveled when you're going in a half circle. So when you go in a half circle, what is the distance traveled? That I'm marking in green here. Which is pi r. Easy. Understood the meaning of that? Putting a mod. If you had kept a mod here, the answer would have been yeah, mod of this, which would have been 2r. So putting a mod inside the integral, outside the integral, it changes the whole meaning. Hope everyone is clear with this mod ka thing. So in this question, right, primarily it's the new thing is the mod ka thing. The remaining things, actually the vector, differential and all that stuff we have done in vectors and calculus. You should definitely go and refer to that once. You should definitely redo it again in case you forgot. Again, I'm telling you, if you forgot something, that is not a problem. The problem is after realizing you forgot, you don't go home, after the class gets over today or tomorrow, you don't revise. That is a mistake. Forgetting is very common. It happens. That is completely fine. But after that, you don't do anything about it. And that is being an idiot. So keep that in mind. Most people mess up because of that, not because they can't remember or they're not good and all. To crack an exam like mains or advanced, you need not be a super genius. If you are, it is good. But you need to have a consistent work. I have seen smart people because they don't have proper, work ethics. They don't revise things on time. They keep postponing stuff, right? They keep getting scared. Like, when you don't understand something, instead of treating it as like an opportunity to learn, they get scared. So yeah, so it is always like that. You see something new, you have two options. You can get scared or you can think, okay, I'm getting scared. I don't know what is this, meaning this is an opportunity to learn. So yeah, even better, you can think of like this. I saw this, I got scared. That means most of the people in the country are going to get scared. That means if I'm going to do this, I'm better than most of them. So be better than most of them, right? Isn't that how you're going to crack the exam? Great. But everyone clear with the steps? Hope everyone understood. Right? You should do it again once more on your own and you'll get it. Now, since you got this, let's do something similar like this. So we have our X and Y axis. We have a particle here at 0, comma A. This is going with speed U horizontally. A particle moves parallel to x-axis. From 0, comma A. You're here at t is equal to 0. This point is your origin 0, comma 0. Find r bar. Find dr by dt. Find d mod r by dt. That is the actual question. Previous case, it was 0. Here it won't be 0. Why? See this thing. Initially, this is r bar. As the particle is going, this is r bar. This is r bar. This is r bar. Can you see now the length of the vector is changing? So here, the magnitude of r bar is changing. So as the particle is going, the r bar vector is continuously changing. So the main question in this is this one, d mod r by dt. Let's get this. The particle is going on a straight line. Find r bar at time t. Find dr by dt. Find d mod r by dt. Hope the question was clear. Anyone the question is not clear, please ask me. So there is a particle going on a straight line parallel to x-axis. So find the position vector at time t, find dr by dt, and find d mod r by dt. Meaning that is the whole question there. Like as the particle is going, the r bar will keep changing, isn't it? What is r bar? The vector from the origin to the particle, isn't it? Your r bar is changing continuously. Anything else with the question? Basically, the question, that's all the data that you have. Basically, you're just going in a straight line parallel to x-axis. Get r bar. That is the easiest one, right? What is r bar? Find x coordinate, find y coordinate. X I cap plus y j cap is r bar. Bas ho gaya. R bar, there is nothing hi-fi about it. R bar is simply your x and y coordinates at time t. Seriously, R bar you guys didn't get? See, R bar was easy. That you should have got it, I guess. So after time t, where will you be? You will be somewhere here. The particle would have traveled some distance here. How much? U into t. So what will be the coordinate? Your coordinate will be ut, comma a. That is your coordinate. What is R bar? R bar is this vector. So R bar is simply ut, that is your x coordinate I cap, plus a into j cap. what is dr by dt? Differentiate this. That will be ui cap plus 0. That is ui cap. Basically, that's your speed, isn't it? Like I said, those two are the easy ones. The third one, the d mod r by dt. What is mod r bar? Mod r bar is root over u square t square plus a square. Now you're asking me to differentiate this one, d mod r by dt, which is d by dt u square t square plus a square whole power half. Hope you guys remember chain rule. This is a function to the power of half. So differentiate this. Half into the function, which is u square t square plus a square whole power half minus 1. Then differentiate whatever is inside. That is u square t square plus a square. This would be half into root over u square t square plus a square, and that would be 2 times u square t plus 0. 2 will cancel. You end up with u square t by, I'll just write it down here, u square t by root over u square t square plus a square. There, that is your d mod r by dt. So basically, this is a rate of change of the length of the magnitude. Meaning, see, every instant if you see, isn't the vector size becoming bigger and bigger? The length is becoming bigger and bigger. So I'm asking you, at what rate is that length changing? This is the rate of change of length of the magnitude vector. This is not speed. In the previous case, you're lucky because the speed was, it was going in a circle. R was constant, so you could got 0, but you'll not be every time. Yeah. Is this making sense, everyone? But what does this even mean actually? Let's try to figure out from there. Manav, Tanmay, please keep your cams on. All clear with this? Now, let's try to understand the meaning of this. This will be very important. If at all they ask you what is d mod r by dt later on, right? If you understand actually what they're asking, what it means, it actually becomes quite easy. You can skip all this differentiation and get an answer much faster if you understand what it means. So let's discuss about that. I'll put a star for this. Listen to this carefully. So the particle was going in a straight line. After some time, you're somewhere here. This was your r bar vector. This was your velocity vector v bar. Let the theta be angle between v bar and r bar. So this angle is also not constant. It is changing every instant. Great. Now, if you resolve this velocity into two components, you get a component here, v cos theta, and you get a component here, v sin theta. Now, u cos theta and u sin theta. Now, ask yourself, what is u cos theta doing exactly here? U cos theta is in the direction of r bar. U cos theta is along r bar. This is responsible for increasing the length of the vector, isn't it? The u cos theta is stretching the vector. This is responsible for increasing the length of the vector. So, but think about that. That means, what is d mod r by dt? D mod r by dt is the rate of change of length of the vector. And you're saying u cos theta is also responsible for changing the length of the vector. So basically d mod r by dt is nothing but u cos theta, length of the vector. So d mod r by dt is u cos theta. There. This is also called as a radial velocity. It's along the radius vector or this thing, so it's called a radial velocity. So d mod r by dt is nothing but u cos theta. Let's see how to get this. That's pretty straightforward. If that is theta, then this is theta. This length will be how much? This length was a, that was given in the question, and this length was ut. And this distance would be root over a square plus u square t square. So d mod r by dt is u cos theta. What is cos theta? Adjacent side, which is ut, by hypotenuse, which is root over a square plus u square t square, which is u square t by root over u square t square plus a square. Same answer. Did you see we got the same thing? With all the differentiation, we got that. But the problem with the differentiation, right, we really didn't understand what it is even trying to say. But once you actually resolve the components, you will realize that u cos theta is actually d mod r by dt. That u cos theta is responsible for increasing the length of the vector. Is that clear, everyone? So once you understand this, right, you need not differentiate, you not do anything. Your job was to find theta at that instant, and you can just say u cos theta and your answer is done. Saves you a lot of time from differentiation. Is that clear, everyone? Similarly, we can still play around. What does u sin theta do? The u sin theta is responsible for changing the direction of the vector. So the two vectors have two roles. One component is increasing your length and one component is changing your direction. Rotating the vector. So we will talk about that later in more detail. So we'll call that thing as tangential velocity, which comes in circular motion. Radial velocity along r bar or along radius. Tangential, it's the tangent, the perpendicular one. But is this clear, everyone? What is d mod r by dt now? So that is something new. dr by dt is velocity. So we wrote it somewhere here. No? I'll add it now. There. So dr by dt was velocity. Mod of dr by dt is speed. D mod r by dt, this is not speed, this is actually radial velocity. Which is u cos theta. I'll just put a small picture here for you to understand. So let's say the particle is going in some weird curve. This is your r bar. This is your v bar, and this is your theta. This component is v cos theta. This is your radial velocity. Yeah. So once you understand the meaning of that, you can actually skip all the differentiation and you get an answer pretty fast. Is that making sense? It has a meaning. It's called radial velocity. It tells you how fast is the length of the vector changing. It talks about the magnitude of the vector. Any doubts on this? So if you see, right, again, this is nothing like, new or something. We have done this with whatever you already know. And this is what happens. They will create something like this and they'll say this is called radial velocity. People will just see the word and they get scared. They don't actually try to get the meaning like, okay, what does it even mean? Even if you don't understand the meaning, if you just use brute force mathematics, you'll still get the answer. Isn't it? So there, this is pure math. If you see in this, there is no physics. Once I wrote R bar, I just took the magnitude and differentiated it. There is no meaning, no understanding. We don't even know what the hell it means. We got the answer. That is fine. You'll get an answer, but what does it even mean? So that helps. Any doubts on this? This one and the previous one are little unorthodox problems. Getting it? These are not standard models, so please make sure to go through them. Generally, these kind of things they don't touch in mains. Advanced main, these are like normal. So great. Let's do something more, little more easier. Let's say a particle is moving along x-axis. Whose x coordinate? X is given by t cubed by 3 minus 3t square by 2 plus 2t plus 1. Now listen carefully. Find the distance traveled. This would be a good mains level equation. Find distance traveled in 3 seconds. Second thing, find the time interval. Time interval meaning from here to here, like t is equal to 1.5 second to t is equal to 3.5 second. That's a time interval. When the particle is speeding up, look at the word speeding up and speeding down. I'm not saying accelerating or decelerating. So the word speeding up meaning speed is increasing. This is completely a different word from acceleration though. I'll show you what it means. And speeding down, speed is decreasing. Generally what people think, right? When I say speeding up, people think like, oh, it is accelerating. Not necessary. People think acceleration is positive or acceleration is negative. Let me show you cases. Let's say we got a body here. Let's say it is going forward. So let me just put 4 of them. Now look at this thing. So acceleration is forward. So that's a positive x-axis. So A is positive. Here A is positive. A is negative. A is negative. Now, if you look at the velocity, it can be going forward also. It can be going backward. It's forward, it's backward. Look at this thing here. So here V is positive, right is positive, left is negative. V is negative, V is positive, and V is negative. So now, if I ask you this question, in which case it is speeding up? Look at here, A is positive, V is positive, both are in the same direction. Speed increases. A is positive, but V is negative, means your acceleration is forward, but your velocity is backward. Here, the speed will decrease. So this is a misconception people have. People think speeding up matlab acceleration positive hona chahiye. Not necessary. You can have acceleration back forward and still speed can be decreasing. So this is also speed is decreasing. This is speed is increasing. So if A and V are in the same direction, speed increases. If A and V are in the opposite direction, speed decreases. Is that clear, everyone? So if I ask you this question, when is the acceleration positive? When is the particle speeding up? They're two different questions. Is that word making sense? Speeding up is different from positive acceleration. if you want to write this in a vector form, this is even more superior way of writing. For speeding up, the angle between a bar and v bar must be acute angle. So a bar dot v bar must be greater than 0. That means the component of acceleration is increasing the speed. This is a vector form, everyone. Speeding down is a bar dot v bar is less than 0. That's a more superior thing. Clear with that? So if I give you a bar and v bar vector form I, j, k, and if I ask you speeding up or speeding down, then the dot product will come. Since we are going on a straight line, this will be fine. Let's get A and B. This would be a good question. Even at an advanced level, this could be good more than one choice question. Let's find the distance first. Then we'll talk about speeding up and speeding down. But anyone not clear with the question or whatever I explained, please ask me. So here, the new word is speeding up and speeding down. Don't confuse that with acceleration. They're completely two different things. Let's see, anyone got the distance? And by 6 and 1 to 1.5 and 2 to infinity. Yeah, right, Prasha, we got it. There we have an answer. Others, what about the distance? Okay, let's see the first part. Now, be careful. Distance, I asked you, not displacement. So you have to be careful with that. Whenever they ask you the distance, when you hear the word distance, have some fear. You hear the word distance, your brain should go into a mode like, boss, something is going wrong. Be careful. If you don't have that fear, you will do the standard stuff. You know what you will do? You'll put t is equal to 0, you'll get x is equal to 1, you'll put t is equal to 3, and you'll get x is equal to something, you'll subtract them. This is not a distance, this is displacement. Right? So what is actually happening with the particle? Let's see. In these kind of questions, whenever they ask you distance, always be clear, like it's a trap. The particle is just not going straight, it is doing some nonsense. So let's see what it is doing. First, let's get the velocity. V is equal to t square minus 3t plus 2. You can clearly see velocity is 0 at t is equal to 1 and t is equal to 2. So basically there are two turning points. At t is equal to 1 and t is equal to 2, the particle is actually taking a turn. So this is how it is looking. When the time t is equal to 0, the particle x is equal to 1. You're starting here. Then you're going forward. Technically, this is going in a straight line. For you to understand, I'm drawing a curve. When time t is equal to 1, the particle is taking a U-turn. Then it is going backward. Then again, it is taking a U-turn. So every time it stops, it is basically taking a turn and then it goes off. Are you clear, everyone? How is this path going? If I actually draw this properly, the path will look like this. It will be on a same line, but you can't see this. So I'm drawing it little, curvy. Is this making sense? The particle is going front, back, and then front. Now you tell me, do you think if I measure this distance, is this distance? That is displacement, right? That's the problem. So whenever they ask you distance, you literally have to calculate the whole path. So let's get the coordinates. T is 0, x is equal to 1. T is equal to 1. What is x ka coordinate? 1 by 3 minus 3 by 2 plus 3 plus 3 by 2, 1 by 3, 9, 11 by 6. T is equal to 2. You just have to substitute here. 2 cube by 3, 8 by 3, minus 3, 2, 6, 5 plus 1, 5 by 3. T is equal to 3. 3 cube by 3, 9 minus 27 by 2 plus 7, 9, 7, 15, 15, 3, 30, 30, 3, 2, 6, 7, 3 cube, 3, 9, 16. How much is this? 27 by 2. That is 13.5, 2.5, 5 by 2. Then I got the coordinates. So t is equal to 1, you're at x is equal to 11 by 6. T is equal to 2, you're at x is equal to 5 by 3. And t is equal to 3, you're at x is equal to 5 by 2. And t is equal to 0, and x is equal to 1. So what's the distance traveled? 1 to 11 by 6, 11 by 6 to 5 by 3, 5 by 3 to t by 3. You literally have to add all that. Yeah, there is no other way to do this. At least I couldn't figure out another way. You literally have to draw the path and you have to see the turning points. So that would be like 11 by 6 minus 1. I'll just put a mod everywhere, 11 by 6 minus 5 by 3. And I'm finding for each section, because you go front or back, you always have to add 5 by 2 minus 5 by 3. Add it up. That would be how much? 5 by 6, 5 by 6, 1 by 3. Yeah, that's 1 by 6, 11 by 6. Check. So if I have to describe this motion, the particle goes from x is equal to 1 to x is equal to 11 by 6, turns back, goes to 5 by 3, and turns back. So you need to find the velocity, see how many times it is turning back, and yeah, you're done. Are you clear with this? So be careful. Just don't take 3 and 0 and subtract them. That will give you displacement. That won't give you distance. All clear with this? Question still not over though. Speeding up and speeding down. How do we do that? So just now we got the velocity. What was the velocity? V is equal to t square minus 3t plus 2, which is t minus 1 into t minus 2. Acceleration is dv by dt, which is 2t minus 3, which is t minus 3 by 2. Now it's a little math here. So look at the limits here. So if I take time between 1 to 0, and if you take time between 3 by 2 to 1, then because see here, if you see 3 by 2, it is becoming 0, t is equal to 1, 0, t is equal to 2, 0. So there are 3 zeros there. Three by 2 to 2 and t greater than 2. So basically there are 4 time ranges here. Look at this. First, let's talk about velocity. Now you tell me, when the time is less than 1 second, is this positive or negative? Can you fill up the table? In which time is it positive, which time it is negative? Try, I'll give you a minute. You just have to tell me in which time interval V is positive and A is positive. Just give it a try. So you can clearly see here, if t is less than 1, t minus 1 is negative, t minus 2 is also negative. Negative, negative, positive. Between 1 and 3 by 2, t minus 1 is positive, but t minus 2 is negative. So this is negative. For t between 3 by 2, this is also negative. For t greater than 2, it is positive. Do you guys do something like this in max? I think there is a name for this. They do something in parabola thing. So, but there you can clearly see the function there. What about acceleration? This is straightforward. If t is less than 3 by 2, it's negative, negative. T greater than 3 by 2, positive and positive. There you're done. So if both have same sign, means you're speeding up. Both are opposite, you're speeding down. So V is positive, A is negative, your speed is decreasing. Negative, negative, speed is going up. Speed is going down. Speed is going up. Perfect. So if you want speeding up, mathematically, this is how you write. It's 1 comma 3 by 2 union 2 comma infinity. That's the mathematical way of writing. So the time interval between 1 to 3 by 2 and 2 to infinity, the particle is speeding up. All clear with this? What is speeding up and speeding down? If I ask you, when is the acceleration positive? For t greater than 3 by 2, acceleration is positive. That is completely a different question than asking when it is speeding up. Those are two different questions. Speeding up and acceleration is positive. All clear with this? Clear? Take a break. Come back by 9:40. We'll continue from here. Any doubt so far?
So can you explain again how did you draw that graph? The curve?
Which figure? This
Yeah,
one?
yes.
It's, actually it is just on the same line actually. So I know velocity is 0 at t1 and t2. Think about it. When will velocity be 0? Every time you're taking a turn, see, if you're going straight and if you want to come back, without stopping, you can't come back. Right? If you're walking in a line and you want to come back, what will happen? First, you have to slow down, you'll stop, and then you'll come back, isn't it? So whenever v becomes 0, it's a turning point. You're turning there, back behind. So that's why it always stops. Yeah, but mathematically तुझे check करना है, so then we can clearly see, right? Velocity देखो 0 to 1 positive था, suddenly 1 to 3 by 2 negative हो गया था, 1 to 2. So means it is traveling backward from 1 to 2 till where? Till 5 by 3, and then again it turns and then it goes ahead. This is not the actual path, right? You're getting that, na? Meaning if I draw this, it would look like this, but then you won't understand. So दिख रहे हैं, I'm drawing in 3 colors. ऐसा दिखेगा. सब एक ही लाइन पे है. Got it?
Yes.
Any other doubts? Go take a break. Go away from the screen for 5 minutes.
Sir, I was disconnected. What's the final answer?
This is the final answer.
Okay.
You see, na, wherever it is negative, negative, same direction. Positive, positive, same direction. So that is speeding up, right? If A and B are in the same direction, it is going faster. If A and B are opposite, it is going slower. Clear, Shlok? Understood, na, how we got the positive, negative thing?
Yes, sir, I understood the positive negative wala graph, wala table you've made, but how did we get 1 comma 3 by 2 union 2 comma infinity?
So 1 comma 3 by 2 and t greater than 2 is speeding up. So you're asking how did I write this? That is a mathematical way of writing
Never
like
mind.
the time range. So,
Yes, sir, I understood.
no? Yeah. Okay, let's start off. Campaign everyone. Great. So far we have seen all this average velocity, average speed, all that stuff. Now we will go into more specialized this thing, uniform accelerated motion. So what is uniformly accelerated motion? When acceleration is constant. So that means there will be no integrations or anything involved here. It's a good thing in a way, right? So Acceleration A is equal to constant. Others, do keep your cams on. So what are the three equations? If you remember, we have derived them in integration. So V is equal to U plus AT. S is equal to UT plus half AT square. V square minus U square is 2AS. Be careful, these are valid only when A is constant. If A is not constant, then what to do? Integration. We have to double integrate and we have to get them added for constant acceleration. If A is changing, you can't use these things. U is initial velocity. V is final velocity. S is displacement and T is time. We'll follow a simple sign convention. Today we'll be dealing only with the horizontal motion. Next class we'll be dealing with the particles thrown up and down. And this will be the foundation for the projectile motion. What happens if you throw at angles? So up is positive, right is positive, left is negative, and down is negative. Example, if you have a body there and let's say velocity is going backward, u is 10 meters per second, and let's say acceleration is 2 meters per second square. When you substitute these in the formulas, you have to put u is equal to minus 10 and a is equal to plus 2. So be careful. The signs are important. Let's say the body is going down with 2 and acceleration is 1. Same thing. In the formula, you have to put u is minus 2 and a is equal to minus 1. We will stick to one convention, okay? You can actually take down also positive, anything as positive, but let's stick to one convention. Don't get confused. So we'll always take up positive, down negative, right positive, left negative. Clear with this? Tanmay, cams on, Manav, Dhruv. That's it. So the three equations. So let's see if your questions on this. Let's start off with something straightforward. So at t is 0, the particle has a speed u is equal to 2 meters per second. Acceleration is 2 meters per second square. Find time when it traveled when s is equal to 20 meters. S is the displacement. Find ratio of distance traveled in 3 seconds and a third second. Look at the wordings again. They're completely two different things. 3 seconds and third second. What does it mean? See, listen. Let's say you're going from 0 to 1, 1 to 2, and 2 to 3. So when you go from 0 to 1, this is your first second. 1 to 2 is your second second. 2 to 3 is your third second. But if someone says 3 seconds, that means from 0 to 3 is 3 seconds. I hope you got the meaning of that word. So 3 seconds and third second are completely two different words. Yeah, let's get them both. Formula substitution, that's it. We are going to play with only these three formulas. The particle initial speed is 2, acceleration is also 2. find the time when the displacement is 20 meters and find the ratio of distance traveled in 3 seconds and third second. So in 3 seconds, how much will it travel? Third second, how much will it travel? Get the ratio. Okay. Okay, let's see the first one. See, this is how you always ask yourself, what is given? You have given u and a and displacement. And what are you asking? Time. So then ask yourself, I know s, I know u, I know a, you're asking for time. Which equation will fit this data? V is equal to u plus 8. I don't know v. V square minus u square 2s, there is no time. The second equation fits the data. That's it. That's how you always see, what do I have and what do I need to find? S is equal to ut plus half at square. S is 20, that is given. Speed is 2. Acceleration is also 2. So you get a quadratic equation, t square plus 2t minus 20 is equal to 0. So t is equal to minus 2 plus or minus root over b square, that is 4 plus 8t by 2. That would be minus 1 plus root 21. That's your answer. Check. Root 21 minus 1. Straightforward. Next thing, what do you want to find? Distance traveled in 3 seconds. So 0 to 3. Again, the formula is ut plus half at square. U is 2, time is 3. Half a is 2, time is 3. That would be 6 plus 9, 15 meters. Now you're asking for third second. So what I'll do, I'll find from 0 to 2, which is u, which is 2 into 2, plus half 2 into 2 square. That would be 4, 4, 8 meters. So can I say like this? The displacement in the third second is nothing but displacement from 0 to 3 minus displacement from 0 to 2. I will find the distance traveled from 0 to 3. I will find the distance traveled from 0 to 2. And if I subtract them, जो बीच का जो बच जाएगा, isn't that the third distance? Third second का distance. So that's 15 minus 8, 7 meters. So you're done. So the ratio is 0 to 3 by third second is 15 by 7. So in third second, you traveled 7 meters. What is third second? From 2 to 3. So what I did, I found the distance from 0 to 3. I found the distance from 0 to 2. And when I subtract them, so the balance is from 2 to 3. Is that making sense? So there is no need to think too much. Like, yeah, there is a formula for nth distance. We'll see that also, but this is the basic idea there. Any doubts on this? There we just use that one formula, S is ut plus half at square. All clear with this? Radhika? Dhruv? Clear with this? Anish, you got it anyway. Manav, clear with this? Rohit? Yukti? Soumya? Shreya? Tanmay? Great. Let's see one more. Now, here I'll just write down the displacement in nth second. Because you will see this in some books like a formula. So nth second is nothing but distance traveled in n seconds minus distance traveled in n minus 1 seconds. So this is u into n plus half a n square minus u into n minus 1 plus half into a into n minus 1 ka square. Subtract them. You end up with u plus a into n minus half. Okay. This is the formula for nth second, but be careful. This is displacement, not distance traveled. Yeah, in exams like CET, this itself is a question. They do ask. Anyway, not too difficult, but you can get it. All clear with this? Great. Let's do one more. Let's do an easier one. So let's say we have a vehicle. This is point A, this is point B, this is point C. When the vehicle is at A, the speed is 20 kilometers per hour. When the vehicle reaches point C, the speed is 50 kilometers per hour. At speed B, we don't know the speed. But we know the distance AB by BC is 1:3. Means if A to B is 1 kilometer, then B to C is 3 kilometers. This much we know. So a vehicle is going from A to C with a constant acceleration. So B is somewhere, B comes on the way in the journey. A to B, vehicle moves from A to C with a constant acceleration. So the vehicle is starting from A with a speed of 20 kilometers per hour with some acceleration. How much? We don't know. But when it reaches C, the speed becomes 50 kilometers per hour. Using this information, tell me what is the speed when you're at B. Hope the question was clear. The vehicle is continuously accelerating. We have no idea with what acceleration. But when you're at A, your speed was 20. With that same acceleration, when you continued moving, by the time you reach C, your speed became 50. How much distance? We don't know. But there is a point B somewhere between A and C. The ratio is 1:3. What will be the speed of B? What will be the speed of the vehicle when it was at B? Hope the question was clear. Let's get this. This is a standard model. These are the mains level questions. Like, try. I'll give you a minute or two. Any answers? It's not a great answer, but now when I see this question, what is given? So that is the first thing you should always ask, what is given in any equation? Okay, he's talking about A and C. He said speed is 20. He said speed is 50. So this is initial, that is final. Great. So V is given, U is given. And he's talking about something called AB and BC 1:3 ratio. Means he's talking something about distance. He didn't give me the values, but you're talking about distance. But there is one thing you're not talking about anywhere. Time, isn't it? They're not talking about time anywhere. So then I'll ask myself, okay, I have three equations. V is U plus AT. I can't use because I don't know time. S is UT plus half AT square. I can't use because I don't know time. So the only thing left is V square minus U square is equal to 2AS. So then I will think, okay, let's use this and see. So you said AB and BC is 1:3 ratio. So let this distance be S. Then this should be 3S. Yeah, you can just take that. So when you go from A to B, I'll use the formula V square minus U square is equal to 2AS. You can do A to C also directly, right? Nothing wrong. So VB square minus VA square is 2. A ka value I don't know, S. When you go from B to C, B is the initial, C is the final. So same stuff. So we'll write VC square minus VB square 2 times 2A3S. There, you're done. So this is equation 1 and this is equation 2. Take equation 1 and equation 2 and divide them. You get VB square minus VA square by VC square minus VB square will be 1:3. Cross multiply. You get 3VB square, VB square. 3VA square is equal to VC square minus VB square. So we get VB is root over 3VA square plus VC square by 4. There. You know the values of VA and VC, substitute there. VA is 20, 20 square 400, 403, 1200, 1200 plus 2500. That's 3700, 3700 by 4, 925 kilometers per hour. Yeah, that's your answer. Yeah, right. Most of you got it. All clear with this? Easy. And we just played with one equation there, if you see. Any doubts on this? Clear, na? Dhruv, Radhika, Shlok, Rohit, Manav. Clear? Let's see one more. Going ahead. Tanmay. Clear? We have a wooden plank. So what you did, you took a gun and you fired a bullet. After passing through the wooden plank, it comes out with a speed of 19 U by 20. A bullet passes through a wooden plank. And loses 1/20th of its speed. Assume constant deceleration. So when it is passing through the wooden plank, we can assume it is decelerating constantly. How many planks are needed? So then you said, okay, let's keep some planks, identical planks. Like 1, 2, 3, and n planks. So you took this same gun, same bullet, you fired it again with speed u. You want the bullet to come to rest. So the question is, how many planks are needed to stop the bullet? We did this in foundation also, if you guys remember. Yeah, you can find A and put it also. Nothing wrong, you will get it. Planks are required. See, this is how they'll frame questions. No one will give you V ka value, U ka value, and stuff. They won't ask like that, like what you did in school. Yeah, right here. Get this, it's the standard model. And you must have seen this like. I hope the data was clear. Be careful, answer is not 20, yeah? Because it is losing 1 by 20, don't think like, oh, 20 planks metal stop. No. Right, Prisha. We have two answers. Okay, let's see. Again, see, it is always like this. What data is given, where does it fit? So, so you're saying initial speed is given. Finally, you're saying it is at rest. So I know v and du, and you're talking about planks. So if there is one plank, if it travels some distance s, if there are n planks, it will travel n into s. So the main thing is to realize, boss, there is no time anywhere, but they didn't even give distance also properly, but there is something like distance. So that's the main thing to figure out. So for the first thing, when you write the equation v square minus u square is equal to 2as. So what was the speed? 19u by 20. What was the initial speed? U square. This is 2. Acceleration is how much? I don't know. And let's say 2ad. So let the width of the plank be d. Let the width of the plank be d. Then if there are n planks, the width will be nd. Yeah, so this is your equation 1. So for this guy, if I write the same equation, v square minus u square is 2as. Here v is 0 because you are coming to rest. 2as is n into d. This is your equation 2. Take this 2ad and dump it in the equation 2. So this would be minus u square. This is n times 2ad will be 19 square by 20 square minus 1 into u square. U square will cancel, n square will be 400 by 39. This comes to around 10.2 something. So what is the meaning of this? We need 10 planks plus a 1/4 of a plank to stop. So if you put 10 planks, will it stop? No, you need 10 plus something, right? So we need 10 plus 1/4 of a plank. That means you need 11 planks. If you put 10 planks, you won't stop. You need one more plank. So yeah, you won't penetrate completely. You'll go 1/4 and you'll stop. Are you clear with this? So you write the equation v square minus u square 2as for one plank, and you write for n planks. And then, yeah, since it is the same wooden plank, and you said constant deceleration, we can assume A is same. The width will be nd. Any doubts on this? All clear with this? There, it's a decent question. Little different, not really tough. Any doubts? Yukti, got it. Going ahead. Karthik, going ahead. Next one. We have two trains on a parallel tracks. So let's say we have a train A, we have train B. At T0, both the trains are starting from rest. So listen carefully to this. So two trains A and B on parallel tracks start from rest with acceleration A1 and A2. For time t. Then the accelerations become A2 and A1 for another time t. We don't know the values of A1 and A2, which is bigger, which is smaller. So think of like this. So train A is going with an acceleration A1. Train B is going with an acceleration A2. They do this for some time t. And then this guy acceleration becomes A2 and this guy acceleration becomes A1. And then they travel for another time t. You get in the scenario? So if I tell you in numbers, it will look like this. So train A and B are starting with acceleration, example 1 and 2. After 1 hour, A acceleration becomes 2 and B acceleration becomes 1 for another 1 hour. So the total journey is for 2 hours. You're getting? If it is in numbers, that's how it would look. Find the ratio of distance traveled by A and B in time 2t. Find ratio of the distance traveled by A by distance traveled by B in time 2t. So the total journey 2t. What will be the ratio? The second one, whatever ratio that you get, what is the range of SA by SB? What is the range? Range means what is the maximum and the minimum value. So when you find SA by SB, you will get some function, right? That function ka what is the maximum value and what is the minimum value? I hope the picture is clear. Anyone didn't understand the question, please ask me. We have two trains, both are starting from rest. Initially, A ka acceleration was A1, B ka acceleration is A2. They go with this acceleration for some time t. At that point, both the engines, they decided they'll exchange the acceleration. So the A started going with A2 and B started going with A1. They do this for another time t. Our problem ends at this point. After that, what happens to the trains, we don't care. So till 2t, what is the ratio of distance traveled by A and B? And whatever answer you get, वो answer का एक value आएगा. मतलब answer will come in terms of A1, A2. Mathematically, if you do something, you get a range for that SA by SB. That would be like an integer question. First, let's get the first part. Second part we can think of. Second part is more max. Yeah, right, Prasha. Got both. Right, Anish. Right, Ahana. So let's see the first part. You just have to draw the picture carefully. See. Let's talk about A first. So your A is starting with rest, at rest. Acceleration is A1. So you will travel some distance. How much will you travel? S is equal to, we are using the formula ut plus half at square. What is the initial velocity? 0. Acceleration, A1. Time, t square. Great. Then, now here, this is the catch. This is the mistake what people do. They think the velocity is 0. It is not. What is the velocity here? V is equal to u plus at. This is A1 into t. So in the second part of the motion, the train is not at rest. It already has gained some speed. And now what is the acceleration? A2. Now when I apply the formula again, S is equal to ut plus half at square. So the final speed in the first part is the initial speed for the second part. So that would be A1 t into t plus half A2 into t square. Is that clear, everyone? So the common mistake is people think the speed is 0 here. It is not 0. You have gained some speed. So what is the total distance traveled by A? Just add them up. A1 t square, 3 by 2, A1 t square. plus a2 by 2t square. Is that clear, everyone? That's the total distance traveled by A. The same thing I'll do for B also. Initially u is 0, but this time you're going with a2. Again, we're using the formula S is equal to ut plus half at square. U is 0, half acceleration a2 t square. So when the train reaches here, the speed would be a2 into t. Acceleration has become a1. Now you will travel again. S is ut plus half at square, but your u is a2 t into t plus half a1 t square. Now from here, when you add both of them, you'll get sp, which you can clearly see 3 by 2 a2 t square plus a1 by 2 t square. So basically a1 a2 will flip. Is this page clear, everyone? So the most common mistake here is people think the speed is not 0 in the second part of the motion. Initially your u was 0, but for the second part of the motion, there is some initial speed. Any doubts on this? And now you're asking for the ratio. So let's get that. So if I do SA by SB, 3 by 2 A1 t square, A2 by 2 t square, 3 by 2 A2 t square. And you will see you'll get 3A1 plus A2 by A1 plus 3A2. Check. That's your answer. Now you're asking for the range of this. So look at this. 3A1 plus A2 plus A1 plus 3A2. I can write this thing as divide by A2, numerator, denominator. I divided by A2, right? And if I say this, suppose if your A2 is much, much greater than A1, means you're taking a very large value. Let's say acceleration is 1 and acceleration is 1 lakh. I can take any numbers, right? You didn't give me anything. So I can take anything I want. If A2 is very, very large, so there's the meaning of very, very large, then A1 by A2 will become almost 0, isn't it? If you divide with a big number, that is going to become 0. So if A1 by A2 becomes 0, then this ratio SA by SB will tend to 1 by 3. Means no matter which numbers you take, you cannot have a ratio less than 1 by 3. Similarly, I can do the same thing. This time divide by A1. So this is A2 by A1 by, and you play the same game. This time you say A1 is much, much greater than A2. Then A2 by A1 will tend to 0. Then SA by SB will tend to 3. That means again, no matter what value you take, you cannot exceed 3. That means this ratio SA by SB will always lie between 3 and 1 by 3. That's your range. Is that clear, everyone? So if your A2 becomes infinity, then you become 1 by 3. If A1 becomes infinity, then you become 3. Yeah, but you can never become infinity, so you'll never reach those values. That's why you have, less than or greater than. You don't have equal to symbol there. That's why I said this is more of a max question, the second part. But did you notice something interesting? I didn't give you a single number in the question. I just gave A1, A2, but finally when I took the range, I got a number. And that could be an integer question. Find the upper limit of the SA by SB. All clear with this? Any doubts on what we did? The most common mistake is that only. People think, at the second part, the speed is 0. Then you'll get 1:1. You just have to be careful with that part. Clear? Let's see one more. You can see, right? Questions are like, there's no integration, nothing, kuch nahi hai. You just have to apply the formula. You have to think a bit. The questions are not really straightforward. Yeah, horizontal mein you really don't have too much also. Fir bhi vertical mein we can play a lot, which we will do in the next class. So we have a vehicle. Initially, it is going with a speed of 20 √2 meters per second. with some acceleration whose value we don't know. So vehicle accelerates to a speed of 60 meters per second, and then acceleration suddenly reverses. With the same magnitude. Meaning, think of like this: you're going in a car or something with some acceleration, you're speeding up, speeding up, speeding up. Once you reach 60 meters per second, you suddenly reverse the car engine or something. The acceleration became backward. Find the speed when it comes back to the initial position. So this is your initial position. You can say this is your T0. Always, try to draw a small picture. That helps you a lot to understand. Nee, Anish. I hope the scenario was clear. Your car was starting at 20 route to speed is already there. You're having an acceleration A forward. How much we don't know. You're going faster, faster, faster. Once you got a speed of 60, suddenly you made the acceleration reverse. Means you started slowing down. So will the car suddenly go back? No, right? It will still continue to go forward and then it comes back. So what is your speed when you come back to the initial position? Nahi, Karthik. You got a good answer, huh? Did you guys get a picture? Always try to put a small picture, right, Prisha? Meters per second, yeah. We have one answer. Okay, let's see. So the vehicle is here going with u is equal to 20 root 2. Meters per second. You have some acceleration, so you will go forward. At this point, your speed became u is equal to 60 meters per second. And then you decided to suddenly keep the acceleration backward. Now what happens? You won't stop. You will continue to go forward. Then you will take a turn and then you'll come back here. So the question is find the speed v. This was the picture every, right? So initially, what is this distance? I don't know. So let this distance be some s. Let's take that distance to be s. Perfect. So let's write the equation for the first one. So v square minus u square is equal to 2as. So v will be 60 square. U will be 20 root 2 square. is equal to 2as. That's for the first part. Now for the second part, think about like this. Indirectly, the question has become like this. U is 60. Acceleration is a. You are going back and you have reached here, and this is your V final. What is the displacement here? See, I don't care how you're going. The displacement is this. From here to here is your displacement. The point where the acceleration got reversed now becomes the initial point, and that would be your displacement. Now write the equation, same thing, v square minus u square is 2as. Be careful with the signs. V final square, u is 60 square. Acceleration has become backward, so minus a. Displacement also became backward, so minus s. Is that clear, everyone? The displacement is same for the starting part and the second part. So you're done. So take 2as and dump it here. So this would be v final square minus 60 square is equal to 2as, which is 60 square minus 20 root 2 square. This would give you v final 60, 60, 3600, 3600, 7200. That's 800. 60 square, 60 square. 3. How much is 20? Okay, that's a minus sign. 7200. 6400. So 80 meters per second. Yeah, right, Karthik. Is this clear, everyone? So you divide the problem into two parts. First part is from the starting point to the point where you reverse the acceleration. After reversing, the second part. So from the point where you reversed it till the point when you come back. Is this clear, everyone? Yeah, so you have to take a negative sign, you have to be careful. So there, you can just keep going with more and more the horizontal motion, but I think roughly you got the idea. So this is how you play around with this. So, okay. So with that, we'll wrap up for the day. So next class, when we catch up on Wednesday, we will start off with the vertical circular motion. So here we are throwing everything left and right. Now we will throw up and down from our buildings and all that. We will also introduce some calculus-based problems here. So up and down will be good. So if you know how to do up and down, you already know how to do left and right. When we combine them, then we start getting at angles, the projectile motion. So when you're clear with this, that look becomes easy. Like I keep saying, what we are doing is we are building small things, and when you add them, it becomes advanced. Advanced is nothing but 3 or 4 easy equations combined in a way. If you can't handle easy and moderate, advanced becomes difficult. Okay, with that, we'll wrap up for the day. So next class will continue from here. Make sure to solve. We did almost 17 questions, right? In some questions, there is A, B, C, D, E, F, G. There are a lot of parts. So especially, I want you to go through this again once more. What is this d mod r by dt and stuff, right? Okay, so I'll see you guys again on Wednesday. Same time, we'll continue from here. So any doubts, anything else, please stay back and ask. Also, you're free to leave. So